All right, now we're on to everybody's favorite topic. I know we can't get enough of this, but that's your box fill. Uh, Again, I know we hit this pretty hard just about every other midterm and final, but I got to share with you, I just wrapped up doing the review for the year 4 core competency, and guess what, guys? We reviewed this. This is not going away. It's going to show up literally on the last test you take as an IEC apprentice. The good news, you will get a little bit of a break in year 2 and 3. However, it's obviously an important topic. Otherwise, we wouldn't see it featured as heavily as we do. So anyway, we have to go back and review this. I'm going to tell you right now, this is going to be the same exact review. I think it's even using the same problem as we did in the midterm review. But to give you the Cliff Notes version, basically I need to come up with my volume allowances. For my current carrying conductors, a current carrying conductor being a hot or a neutral for our purposes right now, I'm going to take a single volume allowance. So if it's a number 12, I'm going to count one number 12. If it's a number 14, I'm going to count one number 14. That's about as straightforward as we can be here. For the grounds now, again, that first thing we covered was current carrying conductors. Grounds are not current carrying conductors, so how do we handle them? In a nutshell, I'm going to take one volume allowance based on the largest conductor in the box. The largest grounding conductor in the box. So if I have some number 12s and some number 14 grounds in the box, 12 is the largest. I'm going to take one volume allowance based on a number 12. Internal cable clamps next. I'm going to take a single volume allowance based on the largest conductor in the box. Doesn't matter if I have one cable clamp, if I have two, if I have 10 cable clamps. If I have at least one internal cable clamp, I'm going to count a single volume based on the largest. No more. If I have 10 cable clamps, I'm not going to take 10 volume allowances. I'm still going to take one volume allowance. And then the last thing that you guys really need to be aware of is your devices. I'm going to do a double volume based on the largest conductor connected to that device. Now, I am going to have to count this for multiple devices, and we'll look at an example, and it'll become clear what I mean by that if it's not already. So, first of all, a couple tables we need to be aware of here out of the code. First one is 314.16a. That's the table that tells you how many cubic inches, which comes from this column, how many cubic inches are in various types of boxes. The test may ask you what's the smallest, 4 square box I can fit this many things in. So basically you're going to calculate the volume of the box, or calculate the volume required, I should say. Then you're going to come to this section here, which is your 4-inch square, not to be confused with 4 11/16 inch square, but your 4 square box. Which one can I have? I'm going to come over here and check the inches cubed that are available in here and pick the smallest one that I'll fit in. Right? And again, remember this second number here is your depth of the box. So that's the first table we need to be aware of. Second table we need to be aware of, 314.16b, as you can imagine, is only a page or so away from A up here. But this is the one that's going to tell you how many cubic inches for any conductor. What's the volume allowance for any given conductor? Right, some good ones to keep in the back of your mind. A 14 is 2 inches. A 12 is 2.25 inches. A 10 is 2.5 inches. Keep those three in your mind. You can do these a lot faster that way, right? So here again, I believe this is literally the same picture we used for our midterm review, but it's a good problem. It covers all bases, so I'm going to use it again. So in this case, we have a 14.3 coming into the box. We have a 12.3, or I'm sorry, a 14.2 coming into the box. We need to keep in mind here that 14.3, the 14 means there's 14 gauge. There's 3 of them. That's what the 3 stands for. The 14.2 means we have 14 gauge. There's 2 of them in the cable. Again, the 2 refers to the hot and the neutral. The grounds are implied. We're not talking about the grounds when we say 14.2, 14.3. So anyway, the first thing I like to do is kind of make my little tally marks, right? In this case, we only have 14s in the box, 14 gauge wires. So what I'm going to do is I'm going to go, okay, let's count first the current carrying conductors, which is our hots and neutrals, right? I have I can basically go by this, can't I? I can say I have 3 conductors here and 2 conductors here, or I can go 1, 2, 3, 4, 5. Regardless, I've got 5 of them. So there's a group of 5. I'm not going to do the diagonal slash. So there's 5. Next thing I usually like to count up is my grounds. I'm going to do a single volume based on the largest ground in the box. In this case, we only have 14s in the box. So my largest ground is a 14. So I'm going to count a single volume 14 gauge. So here's one more we just had. Do I have internal cable clamps? Sure do. In this case, I actually have 2 of them. But remember, we're only going to count a single volume based on the largest conductor in the box. Here's my cable clamps. 1, 2. My largest conductor is a 14, so I'm going to count a single volume 14. Last thing we got to count is our devices. I have 2 different devices here. So this, again, 14 being the largest conductor in the box. This switch has 14s connected to it, so I need to count a double volume based on 14. So I go 1, 2. The receptacle, same thing. I have a double volume of number 14, so I have 1, which makes 5, and then I go 2, right? That pretty much covers everything we need to cover for box fill. So I have a total of what? 5, 10. I have 11 conductors in this box, right? If we remember, or if not, we check that we need to include 2 cubic inches for the number 14. I'm going to take my 11 conductors times 2. Naturally, that gives me 22 cubic inches. I need a box that can contain 22 cubic inches. So if the question was, which the minimum size 4 square box you're going to use, I'd come back up here. I'd say, okay, I need 22 cubic inches. Can I fit it here? Nope. Can I fit it here? Nope. We just missed it. So I bump up to this guy. I need a 4 by 2 1/8, right? So there's how we're going to tackle those box fill questions. Like I said, guys, not going away on the box fill anytime soon. So, keep it in the back of your mind, whatever you do. Next up, moving right along to conduit fill. Here again, we essentially need to keep 2 tables in mind, right? Again, these hopefully all this sounds like review and sounds really familiar, but in this case, we need to go to our good friend Chapter 9 in the back of the NEC. We need to know about Table 4 and Table 5 for this exercise. Table 5 is going to tell you what is the approximate area, cross-sectional area of any given conductor. So that's this column right here, approximate area in inches squared. And then along the left, we have different insulation types. So again, you need to be cognizant of what type of wire are you dealing with. Most commonly, it's going to be THHN. Now this is a multi-page table. I've only pasted the page from that pertains to THHN, but you're going to have to page through this table and make sure you're on the right page for the right insulation type on the left-hand column here. So again, our THHN is going to be found sort of, well, starting here, right? They break it up here at 300. I'm not entirely sure why they do that, but then the second table we need to know about is Table 4, which, as you can imagine, is the table right before Table 5. Because most times we're going to have more than 2 wires in our conduit, we're almost always going to be using this column, over 2 wires in inches squared category. So we have our trade size of all of our conduits. How many square inches can we fit in that conduit here, right? So the exercise is going to look something like this. They're going to tell you, and let's actually just throw out a couple pieces of wire we're going to try to fit into this thing. So let's go ahead and say we're going to do, I don't know, 4, let's give ourselves 6 number 6s, right? How about that? 6 number 6 AWG. Let's make that a little bigger so you guys can actually see what we're doing. So we're going to give ourselves 6 number 6 conductors. Okay, so how do we handle that? First thing we got to do is figure out how many square inches that's going to take up. So to do that, whoops, and it looks like I deleted my table here. We'll get there. Okay, so let's go 6. Number 6, AWG. Okay. So first thing we got to come up with is how many square inches are these 6 number 6 is going to take up in a conduit? And again, if we're not told otherwise, we're going to assume THHN. So I'm going to come up here to look at the THHN section. I'm going to find my number 6s. I'm going to say how many square inches is one number 6 good for? Or how many square inches does it take up? And the answer is 0.0507 from the table here. So I'm going to say 0.0507 times 6, because I have 6 of these. It's going to take 0.3042 square inches to contain all of that. So then what I'm going to do, and what I didn't mention is again, table 4 is specific for whichever type of raceway we're using. I've only pasted the section here from EMT. Make sure when you look at the table, you're looking at the right section based on the table heading here, right? But again, let's say EMT. What's the minimum size EMT I can contain 6 number 6s? Well, I'm going to say, okay, I have over 2. Let's come down here, find one that is bigger than 0.3042. I'm going to scan the column here. It happens to be this guy here, 0.346, which is a 1 inch. So that means I need a 1 inch EMT to contain that. So there is your conduit fill type of problem for the test. A few of those on there. Not as heavy as the D rating questions. Again, for whatever reason, they really hit those hard. I'm not sure why they did that so hard, but then sort of tagging along, maybe lightening up a little bit, is the Ohm's Law stuff. Ohm's Law is going to remain vitally important for your entire career, not just the IEC here, especially in year 1. So make sure you're familiar with Ohm's Law, or at least know where to look up something like this, Ohm's Law wheel. You're going to have to use Ohm's Law to manipulate various, circuit problems all over the place. That's not going anywhere. And you will see some problems where they might just say, here's a piece of equipment. It's got a, it's 2,000 watts at 240 volt. How many amps is it? They're basically telling you to take those two values and apply Ohm's Law to it, right? Now, the problems where they say, hey, here's the thing rated 2,000 watts at 120 volts. What happens if I operate it at 110 volts? That problem's not going away either. The answer to that is, and without dragging you guys into it, is find your fixed resistance, right? Those actually, I don't believe, show up on the test, so I'm not going to drag you through that now, but I've been telling you that, I should say this, they don't show up on the test directly, but they will show up on the test somewhat indirectly. And you can probably guess, as you look at the next 3 things, where they might show up, right? That is your series parallel combination circuits. They keep those calculations to a little bit of a minimum, but we definitely need to hit it because they definitely show up again. It's particularly your combination circuits, which in my opinion are one of the most challenging sections of year 1. So we'll hit that in the next section of video.